So this is the first problem of today's contest. My screen is visible, right?
Yes.
Okay, so in this problem, we are given that two players are playing the game and they start with a pile of stones. So they then take turns removing exactly A or B stones from the pile, and the player who is unable to make a move loses. So we have to find a positive integer n such that the second player can always win irrespective of what the first player's move is. So in this game, both of these players can only remove A stones, exactly A or B stones. So let's say at the beginning there was some n stones, so first player can either remove A stones or B stones. So after this, both of these, like the remaining stones, let's try to finish this game in exactly 2 turns, right? So let's say after this turn, B can always make a move and make the total number of stones equals to 0. So what we can do, at start, we can keep n as A plus B. So if we keep n as A plus B, then after first player's move, we will have B stones left. And if this was what A's, these are the number of stones if that A removed, so we'll have A stone. So either it's A or B or A. So second player can always remove either of these stones and the final number of stones will be 0. Is it clear?
Yes.
Okay, so let's look at the code. So this is the code. I don't think that we have anything here to discuss. So let's directly jump to second problem. So this is the second problem. In this problem, we were given that we have an positive integer n, and max is basically max for a collection of integers is defined as the smallest positive integer x, which does not occur in the collection C. And primality of an array A to A1 to AN is defined as the number of pairs L to R such that the subarray of elements that are from L to R and max of this subarray of all the elements in this subarray is a prime number. So prime number is an any number which is more than 1 and has only 2 divisors, 1 and that number itself. So in this C, if we have some array A and we have a 1 here, so any number of subarrays that you can form in this part will have max as 1, right? You can select any L and any R in this range and you'll always get max as 1. Also, in this part, you can select any L and R if both L and R are in this part, and if both L and R are in this part, you'll always get max as 1. If you want max to be other than 1, you'll have to select L from this side and R from this side. So in order to have, what are the total number of subarrays? Those are number of possibilities of choosing L. Let's call these as L dash into R dash. L dash is number of number of ways to select L from prefix of position where 1 appears. Okay. So then similarly, R dash is number of ways to select R from suffix of position of 1. So now if you L dash and R dash are connected by this equation, n minus L dash, maybe something like this. One, you have 3, let's say you have 2, it will be, if let's say my 1 is here, I have 2 possibilities for L and n is 3, so L plus 1. So this is how R dash and L dash are interconnected. This equation governs the relationship between L dash and R dash. So if you substitute your R dash in this equation and you derive it, so I'm not going to get into that part. If you derive it, you'll find that it's optimal to keep 1 at the center, because you'll get something like maybe R dash square If you substitute L in this, you'll get L square term. And if you derive it, you'll get something like 2L and something here. So basically, it's optimal to keep L1 at always this center. So your 1 is decided. So try to have maximum number of 2's, like maximum subarrays. Try to get maximum subarrays which have max as 1. So for that, keep this 2 as far from this 1, right? And now one more thing, where will you keep 3? See, if you keep 3 here, for this subarray, you'll get some max, maybe as 4 if 4 isn't appearing here, but you won't get max as 1, 2, or 3, right? So it's optimal to keep 3 at the other side, because if you have L here, like if this is the starting of your subarray, for all of these positions, you will get max as always equals to 3, and 3 is a prime number. Otherwise, if your L is not at this position, it is at this position, you'll always get max as 2. So this way, you will get maximum number of subarrays which have max as prime. Is that clear? You can create this answer vector in other ways also, but this is how I did it. Is it clear?
Implementation.
Okay, so let's move to the implementation. So this is the implementation, and in this first I'm taking n as input, then m is the midpoint of array A, and I'm initializing it as 1. So if my array has only size equals to 1, if n was equals to 1, I'll output simply my array A and I'll continue. If my n was 2, then I don't have any options. I can either have a 1 and 2 or a 2 and 1. So in either case, you'll get the same number of primes in for the total subarrays. So just make, since I'm taking m as n by 2, so in case of 2, my m is going to be 1. And so for the 0th index, I'm going to initialize it as 2, and I'm going to output my array and continue. Otherwise, I'm making my first element of my array as 2 and the last element as 3. And for all the elements in between, other than the mth index, I'm making all of those elements in increasing order, like 4, 5, 6, 7, 8, just skipping this index. And then afterwards, all of this is done. When all of this is done, I'm printing A. Is it clear?
Yes.
Yes. Okay. So let's move. It's clear to everyone, right?
How you outputting a
Okay,
array?
don't worry. Like this is not allowed in C++, but just assume I have a template. So you cannot actually do this. You'll have to output array as for, like, you'll have to loop through it. Okay,
Yes.
can I explain the R is equals to n minus L plus 1 part? See, it's not R, it's R dash. So by R dash, I meant that if I have my 1 as here, how many possible places are there at which I can end my subarray? These are the places, right, where I can end my subarray, and I'll have 1 in my subarray. Similarly, L is nothing but how many positions are there, valid positions for my subarray to start, such that there will be 1 in my subarray. So these are 3 positions. L dash is 3. There are 3 ways to start, 3 positions where I can start my subarray, and R dash is 5, right? So what was the number of elements? N is nothing but, in this case, N is 7, right? So if you try to find how L dash and R dash are connected, you will see that L dash is n minus R dash plus 1. Is that clear? Okay. This is clear to everyone, right? Okay, so let's move to the third problem. So this is the third problem. In this problem, we are given that we have n mysterious particles on a line with integer charges C1 to Cn, and we have a device that allows us to perform the following operations. So we can choose a particle and remove it from the line. The remaining particles will shift to fill the gap, and if there are 2 particles X and Y directly to the left and right of the removed particle, they'll combine to give us a single particle of charge X plus Y. So this is just the explanation of what's happening in this case. And in case we removed a particle from the beginning, then it will just be removed. And this particle, if we remove -3, we'll have 1 at the beginning. So let's see what's happening in this problem. See, let's say these are the particles. Can we see at the last we'll have only one particle, right?
Yes.
So now is there any possible way to have like some of the particles, let's say this particle, and this particle will be contributing to our this one final particle, like all of these values, this one particle will have A of 0, let's call this C of 0, C of 2, C of 7. So this last particle will be having C of 0 plus C of 2 plus C of 7 charge. But is there a way to have this last particle include both of these charges, like 2 consecutive charges? Think about it and let me know. Is there a way to have this, like the last particle which is left to me, is there any possible way that that particle has a charge which
No.
has sum of both of these particles? Why? Because see, at the last, I just want one particle. So even if you removed all of these particles and all of these particles, you'll have to remove either one of these. Otherwise, if you remove, like you'll have to remove either this or this. Is this making sense? You will have to remove one of these two, either both or either at least one. Is it clear?
Yes.
Okay, so now let's see what's happening when we are removing a particle. When we remove this particle, these two particles will have their charge added, right? And now let's say if we remove this particle now, these two particles will get their charge added finally, right? So what we can see, we can either remove a subarray of size 1 or a subarray of size 3 or a subarray of size 5. Right? If these two particles get added to this final charge, if we remove this particle, we would have removed these 5 elements finally from our array. So we can always remove a subarray of size 1, 3, 5, 7, like this. We can always remove odd sized subarray from our original array. We cannot remove 2 consecutive elements or 4 consecutive elements from our subarray, from our original array. Because in order to remove only these 2 elements, you cannot simply do this. Like if you remove this element, these 2 elements will get added. These 2 charges will get added. So if you remove that element, you're also removing this now. Similarly, if you started removing with this. But there is a catch here. We can remove these 2 elements if these 2 elements appeared at the last of the subarray, because then I'll first remove this and then I'll remove this element, right? But other than that, if I had some element here, then I cannot remove 2 consecutive elements. But if I start from either side, I can remove any number of elements. I can remove 3 elements or I can remove 4 elements. Why? I'll start from removing from the ending and I'll move towards left. So first of all, is it clear that if I'm trying to remove any elements from between, I can always remove a subarray of size odd length. Okay, it's clear. So now what we can do, see, if I'm at this position, let's say this was the subarray, I can never have this element included to, let's not worry about these values, but I can never have this value included to my answer if I'm having this value included to my answer, right? So either I can take the maximum value which was at this position, which I got at this position, or the maximum value at this position. Why? Because in that case, I'll be removing 3 elements. If I took this, then I'll be removing this element, or similarly, this position. So what I'm trying to say, you can just iterate over odd indices first and then even indices. So let's say we are iterating over odd indices. So when we reach at this position, just find what is the maximum value that you could get in at these positions. So if you get, let's say you had X as your maximum, you can simply add X to this value. And again, like you'll have to push this value in some data structure. So at a later stage, you can again find what is the maximum value for like at all of these indices. But how to get this maximum value inserted and how to find the maximum value that you have, you can use multi-set, right? Or a set. You can use any of these. You can use a multi-set or a set. And let's first iterate over all these odd indices and try to find, okay, for this, we have nothing that we can have previously, right? So let's say for this, you can just have C of 0, right? For this, in your multiset, let's say there's a 0 also. Why there's a 0? Because it's possible for you that you are not taking any of the elements before this. You are just taking this element, right? It's possible that, like I said, you can remove both of these elements. So if you did this, then for this positions, you can get star MST. Let's call my multiset is MST dot R begin, and this will give you 0. Why? Because if at this positions I have -8, there's no benefit in including this in your final answer. So just remove this. So in your multiset, insert initially there is only 0, and for each of these values, find the value which is A of I plus star MST dot R begin, which is this value. This value, right? So this is the most optimal or maximum value that you can get at this index if you're looking at just the elements which occurred before this element. And finally, when you reach this place, you'll have the maximum for each of these positions, right? For each of these odd indices, if my indices are starting from position 1 or odd places. So then I'll have maximum for each of these places, and then I'll do the similar for even places. Is it clear? Is it clear? Yes, no, anything?
So we find the maximum sequence at odd places.
Yes, like you can always remove either 1 element, 3 element, or 5 or 7 like this. So one of the ways to do this is you just iterate over odd indices first and then even indices. And for each index, try to find what is the maximum value that at any odd index that appeared before this, what was the maximum value. So if that value is more than 0, add it to this place because you are getting some positive contribution from some place that appeared before, right? This is one of the ways to do it. You can do it in other ways also. Just make sure that you are having, like you are only removing either a subarray of size 1, 3, or 5 if you're trying to remove the subarray from in between. And if you're removing elements from either start or ending, you can remove any number of elements. Is it clear?
Yes.
Okay, so let's go through the implementation once. So this is the implementation. In the beginning, I have my answer as maximum element that is in my array. Don't make sure that you're not making this as 0 because it's possible that all the values in your array are negative. So in that case, and like finally you should have at least 1 element in your array, right? So in that case, you're going to have final charge as negative. So make sure that you're not making this as 0. Other than that, I have this multiset, and in the beginning, I have my multiset initialized to 0. Then I'm iterating over all these multiples of 2, like all the indices which are multiples of 2. And then I'm inserting this AI plus the maximum value that I could have received from any of the indices that appeared before this ith index and which is also a multiple of 2. So I'm inserting this in my multiset. I'm again taking the maximum value that I can get from this multiset. Then I'm doing the same thing for the odd indices also. And now what is this? Like this is like what can happen here is consider that since I have inserted a 0 in my multiset, there is a possibility that all of my array elements were negative. So what I did here is I made like the biggest element or the maximum element in my multiset is 0 now, but that 0 was not available to me in my array. So in case that my maximum element in my array is less than 0 and my answer is 0, I'll again make my answer equals to maximum element of this array, because in that case you have none of your elements more than or equals to 0. So you cannot get answer equals to 0. You'll have something as negative. You got 0 because of this thing, right? And finally, I'm printing my answer. Is it clear?
So you are saying that the answer will be some prefix of numbers at odd sequences or even sequences.
Yes, you cannot have both even and odd indexed elements in the final answer. Both of those elements cannot contribute. Why? Because if you take an odd element, odd indexed element and an even indexed element, the number of elements that you'll have to remove will be even. You'll have to either remove 2 elements or 4 elements between these, right? And there is no possible way to, let's say, this is my first element. I have my second, third, and fourth. So this is an odd indexed element. This is an even indexed element. If you want to have both of these elements in your final answer, like both of these values added in your final answer, you'll have to remove an even number of elements. So there is no possible way to remove even elements. What is MST? See, MST, if you're not familiar with multiset, you can use priority queue. It's same as priority queue dot top, the maximum element. Is it clear?
Why is it only the prefix?
Like I'm not actually at this, when you'll reach the final place, you'll have the maximum value that you can get. It's same as cadence algorithm. You start from one side and you try to find what is the maximum sum subarray, right? It's not about prefix. You start iterating from left side and you try to find what is the maximum subarray, what is the subarray with maximum sum possible, right? So this is the same. Is it clear?
Yes.
And someone asked me what is multiset.begin. Is it clear? Like you don't have to use multiset. If you're familiar with priority queue, you can use priority queue. What does it point to? The last, yeah, no, not the last element. Like it's not like nothing is first and last in a multiset. It's the maximum element. So let's move to the next problem. So this is the next problem. In this problem, we are given that we have a row major order R into C grid with characters. Of characters, A is the substring obtained by concatenating these rows. So let's say if we had a subgrid of character, if we had a grid of characters, let's say n cross m. So we have n rows, and m columns. So let's say this is so the string that we'll get is, first we'll get these 3 characters. Let's say this is A, B, C, D, E, F, G, H, I, J, K, L. So the final string will be A, B, C, D, E, F, G, H, I, J, K, L. So this is the string that we'll get. And what we have to do in this problem is, we are given the length of this string. And we are also, okay. So a grid of characters A is bad if there are some 2 adjacent cells with the same character. Okay. So now we are given this string, and we have to, like, we are given the length of this string, and we have to make any string such that if you make any n cross m grid which has length number of elements, that grid will be good. And by good grid, we mean that none of the elements which share a side should be same. Like this grid is not good because these 2 elements are same, right? So how to do this problem? See, first of all, if we look at the constraints, we are given that n is less than 10 to the power 6. Like the sum of n over all the test cases will be less than or equals to 10 to the power 6. So what we can do, see, we have the length, right? So how many, if we, let's say, if length is equals to n, we have n number of characters. What are all the possible grids that we can form? What are the different values for n and m? Okay, let's call this R and C. R is the number of rows and C is the number of columns. See, R is always going to be a divisor of n, right? So if I have something like 16, R can be 1, R can be 2, R can be 4, R can be 8, and R can be 16, right? If you have all of these values as R, you can find what is the number of columns. In this case, it's 16. In this case, it's 8, 4, 2, and 1. So these are the number of rows and these are the number of columns, right? So you can see that R is always going to be a divisor of 16 because that's the only possible way that this is nothing but these are the two factors of n, right? So R is always going to be a divisor of n. Is this thing clear? Yes, no? Is this clear? So now what we can do, see, first of all, let's have the first character is going to be, let's say, first you can make it, like, see, why do we need this? Because if we have R, let's say if R is number of rows is 4, then we exactly know which character is going to be above this character, right? Let's not worry about the characters that are going to be in front and below this character, but we always know what character is going to be before this character, right? But how to get a character which will be before this? Yeah, how to get this? So we can get this character if we know the number of columns. If we know the number of columns, we can know, okay, let's say currently I have in my string S, this character is at index I. So I can simply do I minus number of columns and I'll get to this character, right? I'm talking about this string. So if this character here, I have number of columns as 3, right? I have number of columns as 3. So let's find which character appeared before H. So H minus 3, 1, 2, 3, it's E. So H before, like, we have E above H. So this way we can find that, okay, this character shouldn't be equals to E, right? So first of all, let's try to find all the divisors. Now let's say we have all the divisors of n. Then we can simply, and by the way, what are the total number of divisors that an element can have? If element is n, what are the total number of divisors that we can have for n? It's n to the power 1 by 3. Okay, so now let's say we have all the divisors. So let's start with some character. Let's say at the start we have only A as only one character in our string S, or let's call this as answer. And then what we'll try to do, we'll try to make, while answer.size is less than n, what will we do? Let's say we have 26 possibilities. Then out of these 26 possibilities, we'll try to eliminate all the possibilities. Like if our n, let's say we had n as something, so we'll try all the columns that we can have, number of columns that we can have for this n, and we'll try to remove like that possibility, that character possibility, if that character can appear for any C above our current character. Is this making sense? We have answer built up, like, let's say this is our string S. We are currently at this position. We'll try to find for all the divisors of n. We'll find, okay, what are the number of columns? And for that, let's say we can get this character above this character. So we'll make sure that initially we had 26 possibilities. Now, let's say we have a C here, so we cannot have a C here. So we'll mark that as not one of the possibilities for this place. Finally, out of all of the possibilities, you can make any, like if we have A, D, Z as the possible values for this position, we'll make it either A, D, Z. It doesn't matter. Okay, what didn't you understand? What part didn't understand? Okay, let's say, see, unmute yourself because then it will be much better for you both, you and me. See, you got the part where I said that if we have R into CSN, then C will always be a divisor of N, and similarly, R will always be a divisor of N, right?
Yes.
Okay, so now let's say this is our string, and somehow we have built our answer till here, and we have to build these N characters. So we are trying to find, okay, what is the character that we can use here? So for that, what will we do? See, we'll find all these, out of all of these characters, which characters can appear above our current this character, right? How we can do that? We can do that by simply using this possible number of columns that we can have for this value of N. If our current character is at I, all the characters that appeared at I minus C can appear before, like above our current character. We'll have final grid like this, right? These are the characters in our final grid. So let's say this is the current index in the string that we are trying to fill right now. So this character can appear before this position or above this position if columns are number of columns are 4. So I'll get four characters back, and I'll find this character, right? So I'll make sure that my current character is not equals to this, the character which is here. Am I making sense?
Yes.
So
yes.
This way you'll have to do for all of the possible C's. Once it's done, if there is like out of 26 characters, if there is like out of all the 26 possible characters, if there is like, let's say there were A, B, C, X, Y, Z, these are the characters that are that are possible for this position. All the other characters may appear above this character in the final grid. Then we can, it's up to us, we can choose any of these characters. And finally, this way we'll build our string for of size N. Is it clear?
Okay.
I think it will be much more clear when you look at the code once. So first of all, how to, like, we didn't discuss how to get those. See, for each time you cannot find the number of devices. See, one of the possible ways to find the devices is using under root n method, right? But this will be too slow because n is already up till 10 to the power 6. So what you can do, you can use a method similar to SPF. So I have used a similar method. So for all of the 10 to the power 6 elements, I have found what are the devices for each one of them. And I have done this in n log n. N is 10 to the power 6. Let's look at. So this is very generic code. There is no algorithm that's used here or nothing hard logic. So what I have done here is, these are the okay, somebody saying that root n also worked fast. Okay, then it's fine. Okay, it worked in 77 milliseconds. Okay, it's good. Maybe you can try that also if that's working. So what I have done, I am marking this div n, and for all of the elements, see, j is going from 2 times I to n, and for all of these j values, I is one of the divisor. So I'm pushing these value in div of j. Finally, this is just telling me about whether for the current place the ith character is possible or not. So I have made this Boolean vector. Now I'm taking n as input. In the beginning, I'm having only one character a in my string. Then okay, so while I'm going from 1 to n, and okay, I don't need this f. Then like I'm reinitializing all my possibilities to true, all the 26 characters. Then for all of these devices of n, they can be marked as the number of columns, right, for a grid. So what I'm doing, I'm converting this to, first of all, this to integer. Then I'm checking if answer.size minus e is more than equals to 0. See, if this value is less than equals to 0, it simply means that currently you don't have that many characters in your answer string that this character, like there can be any character above my current position, right? If let's say you can, if n is 25, so there's a possible way that you'll have 5 columns, right? But if you, the current string is of size only 3, or let's say even 5, you cannot have a character before this. It's only then when you have at least 6 or 7 characters in your string that you can make, like you can, using this 5, you'll get a character which will appear above this character. Like for this 6th character, you can have, there's a possibility that in the final R cross C grid, you'll have this character above this character. So that's what I'm checking here. So if this is true, what I'm doing, possibility of, first of all, answer.size minus e. So this is the character which I want. Like this is the index. Then I'm like this is the character minus a. This will give me, for a, it will give me 1. For a, it will give me 0. For b, it will give me 1, because I have my position, like possibilities, as a vector, right? This is a vector. So that's why I'm doing minus a, and I'll mark this possibility as false. Finally, I'm going through all the 26 possibilities, and if the jth character is a possibility, then I'll push a plus j in my answer, and I'm going to break this loop. Now this is going to happen n times, and finally I can print my answer. So is this clear? Is it clear? Yes, no, anything? Okay, someone wrote, okay, what part you didn't understand? You can unmute yourself and let me know if there is anything. You just have to find, like, for a grid that is having the total number of characters as n, find all the divisors of n can act as the number of columns for a grid, for the grid which is having n characters, right? So now you just have to find the positions or the characters that can appear above my current character, right? So for that, we are just doing, like, we are finding all the divisors of n, and then we are checking that, okay, this is the character that can appear before or above my current character, and we'll make sure that that character is not equals to this character. So initially, if you would have looked, I also talked about that this character shouldn't be equals to this character and this character. Why I'm not checking about this character? Can anyone tell me why I'm not checking this character? Because see, one of the possible values for C is 1, right? I can have 1 as my column. So if I have one column, only one column, then by default, the last character that I had will appear before or above my current character. So it is already taken care by this C is equals to 1. That is, 1 is always one of the divisors of any n. So that's why I'm not checking explicitly for the last character that was in my string, that is in my string. Okay, someone didn't understand that what is this position. See, this is nothing but these are the number of characters that I have till now. If I do minus e is the number of columns that I'm currently considering. So if you move that many characters back, so it will give you the character that can appear above my current character. So this is that character. If I do minus a, I'll get the index for that character. That is 0 for a, 1 for b, and this way 25 for z. Finally, for like, this is the possibility of having that character. I'm marking that possibility as false, so as I'll only get the characters which are possible, I'll only push one of those characters in my answer string. Is it clear? Okay, it's clear to everyone, right? Okay, so that's it for today. Thanks for joining and bye.
Hello, am I audible?